All right. Welcome, everybody. Thanks for coming to our talk. My name is Jason, and this is Dawn, and we work for HP Fortify, doing mobile application assessments, some on iOS and some on Android. Just so we can get a show of hands here, who has assessed a mobile application before? Okay, cool. So we're in good company. If you've never done mobile application assessment before, we're going to try to explain a little bit about how the process goes and what you can do with binary analysis as opposed to dynamic analysis, source analysis, things like this. There's all kinds of ways to attack the mobile application security problem. And so this is one of the most cost-effective ways we've seen, and that's kind of what our presentation's about today. So these are the obligatory who am I slides. And so I'm the Director of Penetration Testing at Fortify On Demand, which is the cloud service for Fortify. We do mobile application assessments, web assessments, all kinds of cool stuff. We have this group called Shadow Labs internally. It's kind of a cool little group of all of our best hackers that we have on the team. This is my daughter. She is 5 years old and amazing. I do a whole bunch of stuff with OWASP. I'm the leader of the mobile top 10. I am also the leader of the iOS cheat sheet and the leader of the Santa Barbara chapter, which is a really small chapter where I live, and a proud husband. So, and this is Dawn.
Hi, check. So yeah, my name's Dawn Isabel. I'm a mobile security consultant, also with Fortify and HP Shadow Labs. I'm a longtime coder. I like Python. I've been known to rewrite people's code in Python if they leave it with me for too long, so keep that in mind if you ever work with me. I also like to hunt bugs every once in a while. I like to craft all the things. This is one of my kids. This is my daughter watching a SCADA hacking talk back when she was, I think, maybe 9 months old. So we start them early in my house. And hopefully she will also like to hack things when she grows up.
All right, so our talk today is about mobile application hacking. There's a lot of tools just starting to emerge with mobile application hacking, especially on iOS. So some of them are good, some of them are bad, some of them are broken, some of them work. So we thought we'd go through kind of a framework that we created. So if you start looking into tools to test mobile applications, especially if you're doing black box tests where you just have a binary, you can go to OWASP, and under the cheat sheet for iOS in the section, there's just like this, cobbled together list of all the tools. And you won't be able to read this because they're all small font, but they all do a little bit of different things. Almost all of them are, command line based, from your jailbroken iOS device. And so that's what we rely on, is the jailbroken iOS device to interact with the applications that are on the phone, so we can hack them. And so this is a lot of stuff, right? I mean, if you're in charge of assessing mobile application and you don't do it every day and that's not your primary job, this is a lot of stuff to learn. All these tools have different syntaxes. Some of them require certain dependencies on your iPhone, on your jailbroken iPhone. It's just a lot of stuff. And so we wanted to make a framework that was easy to work in and do some cool stuff in. So we leveraged some of these tools in our frameworks. Other ones we rewrote, so yeah. So when you're doing a mobile application assessment, really, what are you looking for? So you're looking for these categories of vulnerabilities. So this is the OWASP Mobile Top 10, how it stands right now. It's in the middle of a refresh, and we're taking in data and contributions. But these are the domains and the most prevalent security flaws we see in mobile apps today. And so a lot of these, you can pull information pertaining to these types of vulnerabilities right out of the binary without even doing a ton of dynamic testing at all. So we're looking for these types of vulns: insecure data storage, stuff that's not being encrypted right, transport layer protection, making sure things go over SSL properly, poor leaking of data, sensitive information disclosure, broken crypto. All of these are the types of things we're looking for when we do mobile app assessments. So the kind of too long didn't read explanation is the expertise to do this is really high. A lot of you do mobile apps already, right? So it probably took you a little while. But for people who are normal security people, it's a bit of a learning curve. So testers need better solutions. Non-testers need better solutions. And the other thing we run into too is that if you're a company and you want to get an app assessed, or you want to assess an app you're allowing into your environment, The cost for a mobile application assessment is prohibitively high compared to what you spent on building it or deploying it. So if you outsource the development of a mobile application, you can spend anywhere from $2,000 to $10,000. And then you go to a security company and say, hey, I want to get this app assessed. They're going to charge you almost exactly the same price to do that assessment. And not everybody has that kind of budget, the same development budget that they have for a security review on a mobile app. So hopefully this solution, the framework we're going to kind of talk about, gives a little edge on that problem. Yeah, so is this you? Are you new to mobile? Are you an enterprise with lots of apps that you want to maybe bring in, or lots of apps that you're going to publish? You need to do these quickly. You're worried about bring your own device. So we have a solution, and we're going to show you kind of some of that stuff today. Our solution is quick. It runs an application from anywhere a minute to a minute and a half, usually, to do all the security checks we're going to do. It's black box capable, so you don't need the source code to do this type of security assessment. It's got good coverage and a low expertise barrier. So if you've never done mobile assessments before, you understand kind of what we're looking for, and we're going to explain it. It's automatable, so you can run large batches of apps when you're doing it, and the learning curve is pretty low. So what we want to look at the domains of a mobile app. And so when you're doing assessment, you can do source code analysis, which is this bucket right here. And there's source code scanners that do taint analysis and fancy grepping and stuff like that. And those tools are cool, but this is not about source code scanning. This is about binary analysis, because you don't always have the source code for these apps. So then there's all these tools for working on the binary, and some of them are reverse engineering tools. Some of them are crackers to take off the Apple encryption from the app. Some of them are for hardcore reversing. And then you have dynamic tools that fit in this client bucket right here, which inspect things that get dropped to the file system. They do runtime stuff, and then you have the network server bucket, which is pretty well documented. So you can definitely get in the middle of between your phone and its server and look at what's going on there. And so we're not really covering source today, and we're not really covering network and server. We're mostly covering binary and dynamic on the client side. So that's where we're going to focus on today. So source scanners kind of limit our scope a little bit. You can't tell dynamically what an app's doing when you're assessing it with just a source scanner all the time. I mean, we're a source scanning company, Fortify, but this tool is a binary analysis tool. So we like to get out of our box every once in a while. So reversing and runtime tools, a lot of the tools that have been developed for iOS to do runtime hacking of the application, they've got a steep learning curve. So if you've ever heard of Cycrypt or any of these hooking frameworks like Captain Hook or anything that's supposed to modify the runtime, they're not, there's no easy manual to learn these things from. And so we already know how to do network and server as well. So what's left to do here? So let's see here. So we want to do the binary analysis with no source, and then we want to start looking at the file system dynamically. And all of these are pretty automatable. So here's the OWASP top 10, and this is very similar when you're doing a source code audit. These are the type of things you want to look for. Well, it's the same thing in binary assessment when you're doing binary assessment of iOS applications, right? So for insecure data storage, you want to look at the data protection API designations on all files that get dropped to the file system. This is Apple's way of encrypting a file at any time. So they allow you to designate, these classes on these files, and so you want to see when you're assessing an app what kind of data protection class it has applied to it. Then you want to look for storage in plist files and in database files. These are the primary data stores for iOS. Then you want to start looking at the transport layer. Well, are they using SSL at all? Great. If they're using it, are they using SSL correctly? And so there's some calls and methods that you can look for there. Client-side injection, so since you're using an SQL database, there's obviously SQL code in there. You want to see if they're allowing client-side SQL injection or injection through web views, which are just your browser pop-ups inside your phone apps. So if you're using a cross-development framework like PhoneGap, that's pretty much all web views pretty much all the time. And so You're going to look for cross-site scripting and SQL injection inside of those web views. And all of these things are easy to parse out once you start looking into iOS methods and classes. So the data protection API designations is a runtime check. Storage into plist files and databases, if you're making a framework like we've done, and you'll see how we did it, pretty easy to check for those being dropped and those not having basically data protection API designations called on them. And so if you go down to the list, there's issues with side channel data leakage when you background your app, how it stores that screenshot to do the animation. So that's an issue, but again, that's in the binary when you code it up. That's the class and method that they use, so you can parse that out of the binary. And then all these sensitive information disclosure things like sensitive information over HTTP, logging, using URL schemes that might be dangerous or integrate with a framework that you don't really want your app to be talking to. So this is kind of a laundry list of what you look for, and it's the same as a source code audit in binary analysis. So these are things that we can do with our tool automatically. So in the first iteration of this talk, I said that there might be, we might give out a little gift to the people who came. This is actually not on the uploaded version of the slides, but this link down here is a simple source code scanner for Objective-C for iOS applications. It's really ghetto. It's grep. It's egrep, right? So it's not fancy. It's not taint analysis, but we coded it up in like a couple days, and we thought we'd give it to you. It just goes over domains of your code that could be insecure. So format string vulnerabilities exist in iOS. The exploitation of a format string vulnerability in iOS is very low. Even if you can exploit it, it can cause a crash, it can do other things, but this is just the screenshot we chose to show. There's other checks in there. So we grep through your binary or your source code, and it pulls you out and shows you lines of code that have bad things in them. So this is the first kind of gift that we have, and it also shows kind of the logic that the tool that we wrote uses, and it's looking for classes and methods that are linked to what we showed in that table a couple seconds ago, which was what you need to do in a binary assessment. So now we're going to talk a little bit about the tools, and Don's going to go into that.
Thank you, Jason.
Mm-hmm.
So let's talk tools, because let's face it, that's the fun part. That's the interesting part of where you really get your hands dirty with an app, right? So he asked before how many people have done a test, an analysis of an app. How many people here are developers and develop apps? Okay, cool. So you're going to know about some of this stuff already, but I'm hoping some of these things will surprise you too, because really a lot of these tools, if you test all the time, you're probably going to know about them. But I want to get these out to people who either are new to testing or who are developers and just really don't know what testers even do with their apps once we get them. So the couple of assumptions that we have here are that, first of all, the tests that I'm going to talk about first, the tools, are intended not for runtime. We're not doing dynamic stuff. We're doing static. We're working with the binary. But we do need to have a jailbroken device. We want to have access to the file system as much as possible. We want to have access to what's installed on the file system, be able to actually examine the artifacts that are there. But there's another piece of this as well that's really important, and this is why we have the jailbroken device in the first place, and that's cracking the app. Now, this might not be a factor if you're looking at your own apps or your own company's apps, because you can just get those binaries before they ever hit the App Store and not worry about encryption or anything like that. But if you're doing any kind of black box on App Store apps, if you're worried about BYOD, you want to know what's the risk of App X coexisting with my customer data on people's devices. You're probably going to do some black box analysis downloaded right from the App Store, right? And to do that, to really get a good, easy analysis, a good, quick analysis, we want to decrypt those apps first, strip away Apple's encryption. And the great thing is there's tools to do this. You don't have to figure out how to use GDB and do it yourself, even though if you want to, there's a lot of tutorials out there to walk you through it. But we like Clutch, we like Rastercrack. Between those two, I don't know that we've found too many apps that one of them won't handle. And this will get your app into a state where you are ready to do further analysis. So one of the first tools, one of my favorite tools, when I first look at an app is OTool. How many people have used OTool, know about it? Okay, good. This is new information for people. Great. OTool is free. Apple provides it. If you have a Mac, you probably have OTool. If you've got Xcode or something like that, you probably already have OTool whether you know it or not. And it can actually tell us quite a bit about whatever binary we're looking at. We can get architectures. We can get header flags. We can tell what frameworks the app uses. We can actually get some security information right off the bat. Things like if they're using ARC, automatic reference counting, and making use of that in the binary, do they have PI enabled, which is position independent executable? It's a flag that I want to see if I'm doing an assessment on an app. Are they using stack smashing protections? This is stuff we can get right off the bat just by running OTool. And the great thing is the output of this is all strings. So if you're looking for a way to automate, this is all stuff coming out of the command line that you can parse, you can grep, you can do whatever you want to do to report on it. So here's an example of some output that we've parsed from OTool. And you can see, and Jason will point it out, we have a lot of header information here already. Can you circle the PI flag? I have Jason show you. So we know here PI is enabled. We know a lot about architecture. We know that this app is encrypted. So a lot of times if you're doing this on a random sample of apps, you might want to check the crypt ID in the binary before you try and crack it, because for all you know, it could be decrypted already if you're not really sure what you're looking at. That's something that OTool can tell you as well. And we have a whole list of the frameworks that are used within the app. So if you're concerned about specific things, if you know there are frameworks that are kind of dicey, then this is a good way. Right off the bat, you know, oh, they're using framework X. We don't like framework X. We got to look at this in more detail. Okay. So once you have that unencrypted binary, there's actually quite a bit you can do about it. Anybody here ever work in incident response or do any incident response? A couple of people. So you're working in incident response. You're not a reversing ninja, and you get some random malware binary off of somebody's machine. What do you do with it? You run strings on it, right? I mean, there's so much you can tell. Sometimes you don't even have to put it into IDA or something like that. Strings tells you a lot about what that malware is doing. It's the same thing with an iOS application. Running strings on it gives you quite a bit of information, things like method names that are being used, web service URLs, specific web service calls, parameter names, SQL query strings. This is an interesting one. And think about what a binary needs to actually work, right? API keys, crypto keys, passwords maybe to the back end, all sorts of interesting secrets. If you know where to look, it's all right there. All you have to do is dump it and know what you're looking for. And you have quite a bit of information that the developer probably never wanted you to have. So here's an example. This is a real-life example from just a random App Store app. And you can see we have all manner of SQL queries. Hopefully these are client-side, I'm hoping. I'm hoping these aren't passed to the back end. I hope I don't have to tell you why that would be bad. But right away, you know, even without running the app, without inspecting anything that it drops, we can tell something about database schemas, column names, maybe what the application's storing in the database, pulling out of the database, right? So just this right here, this little excerpt, already tells us a lot about what we might want to know and what we might want to further examine in our application.
This specific screenshot here, if you look and you've done app assessment before, there's client-side SQL injection in these queries, because this is from the tool that we made. And what we do is we parse out queries that aren't parameterized. So in iOS, you're supposed to be using the question mark as the format specifier here, and instead they're using the @ symbol. So some of these might be injectable to client-side SQL injection. So that's one of the checks that we do.
You're ruining all my later slides, you know.
Sorry.
Okay, so getting to Jason's point that I would have made. What do we do with all these strings, right? I mean, it's interesting to look at. If you're a developer, you might be a little scared when you're looking at the strings out of your binary. What can we do with them? If you've ever done any system administration or any automation of anything, you know that the command line tools that are available in a Unix system are really, really useful. And one of the ones just about everybody learns how to use right off the bat is grep. Okay, so we use grep to search through data, to search through files, to do regular expression matching. And it can be invaluable working with the strings out of a binary. All you need to really do is enough research to determine what it is you're looking for. You have to have some sort of consistent way of seeking out something that you're pretty sure is vulnerable, or even that you think is vulnerable. I mean, this could be your early warning system for telling you you need to do a deeper dive on an app. So you might not even need to know for sure But just by getting those right patterns and using grep, you can start to weed through all of those binary strings. So like Jason said, one of the things you can do is parse through all of those SQL strings and identify which ones are using format specifiers instead of actually using parameterized queries. And that could be a huge red flag that something is wrong with that binary. Something is wrong with the way that that was developed. But you can also look for really easy quick hits, like the presence of deprecated methods, methods you know are vulnerable to attack in some manner. Those are really easy to find. Any kind of, anything that you can match on, basically, that you can pattern match on out of those strings in that binary is something that you can potentially write a vulnerability check for. Now, I think you can see it's obvious what the pro is here. This is all really easy, right? It's quick to code, easy to understand, learning curve is low. Most people at the command line who are comfortable are going to know what grep is, going to know how to use it, right? But there is a downside, and that is we are still working with just the static binary. We don't have source code, possibly if we're doing black box. So we might not have context. You might know that, yeah, we had a hit in the binary for something, but your confidence level that it's actually a vulnerability might still be kind of low without that context. And it's going to depend. Every vulnerability that you seek out is going to have a differing context level or a different confidence level in terms of whether it's really a vulnerability or not. So you have to do a little research around this. You have to kind of do some experimentation, see what the confidence level is for a particular check, and you can start to see some float to the top that you have a very, very high confidence level on, that you can start creating scoring systems and things around. And then there's other things that are just going to serve as red flags. They're just going to be a note or an info or a warning of some sort. Still good information, but maybe not high confidence. All right, so let's step back, put it all together. So here's a process. We install the app. We crack the app. We extract everything that OTool will tell us about the app. We dump all of the strings, and then we parse through it, use grep to identify any patterns in those strings that match. We're doing pretty good, right? You can script all of this. This is all easily automatable, right? And we've got pretty good coverage. We saw in the slide that Jason talked about earlier, we're hitting 6 categories in the mobile top 10 just by doing this. That's pretty darn good for a couple minutes of scripting, right? Okay, so how does this look against our criteria for a really good application to actually do some automated analysis? It's quick, check. We don't need source, so that's awesome. We're covering 6 categories, really good. Very easy to automate, very low learning curve. This is starting to look pretty good. All right, there's more, but wait, don't leave yet. We didn't actually run the app yet. Okay, remember I said most of what we talked about, not runtime. There's a little bit that we can talk about that is runtime. That's still low effort, low learning curve, easy stuff. And that's where we get into device artifacts, file system stuff. Device forensics has been around for a while, ever since we started carrying around computers in our pockets, right? People have been looking at the forensics of these things. So it's very well understood, where to find file system artifacts, how to parse them. There's a lot of tools out there. And we can actually start to cover a couple more categories of things that we can test. So data protection classes, we can now validate. Once we have access to the file system, we can actually look at the files dropped by the application and see what protection classes are used and see what data is being stored there. That's a pretty easy check, pretty solid. How about looking for credentials or sensitive data inplists, right? We might know from our binary analysis that it drops plists and it saves some data there. We might not know what the data is, but we have an opportunity once we launch the app, log in, poke around a little bit. Sensitive image storage, same sort of thing. We can also look at client-side injection. If they're loading things into a web view from a shared storage area, that's bad. That's potentially cross-site scripting or something, right? Improper session handling. How many people have used an app that has a remember me checkbox? Or maybe it just remembers you without asking, right? You just launch it and it knows who you are. So how do they do that? Are they storing a cookie? Are they storing your password? Is it in a plist? So these are things you can start to look for. Side channel data leakage. I think a lot of people are surprised in developing applications how much data lands outside their application unintentionally. Things that land in logs that they forgot about, things that land in the URL cache, people's passwords landing in the URL cache, and they didn't even know that they were there. All their sensitive data protected by a password in the URL cache, right? So these are artifacts that we can start to look at to get a little bit further in our assessment. And like I said, lots of tools. You don't have to do this from scratch. This is territory that people have gone before. They've written tools. You can use the tools. We have tools to read cookies, to monitor files in real time, to dump the keychain, to show you the logs, and to parse data protection classes on files. So this is all stuff that's out there. There's a downside, right? These are all written by different people, different languages. There's no consistent command line interface. All the switches are different. I know about you. I have a bad memory. I have a terrible memory. I have to Google stuff all the time. What was that switch that's going to show me that thing that I really need for this assessment? So this is territory where we start to go off the rails a little bit. We're losing time trying to remember what we did the last time, trying to remember which command line, which tool, etc. So let's walk back. Let's put it all together again. We already saw the first steps. That all looks really good. Now we're adding launching the app. This is also something you can script on a jailbroken device. Launch the app. Maybe you log in. If you have enough time, you're logging in, you're clicking around. And then you're looking at file system artifacts, you're parsing them, you're using some of these tools to figure out what's there. Okay, again, how many people like Python here? Oh yeah, you can wrap this in Python. How many people like Bash? You can totally wrap this in Bash. We're going to show you how to do that, right? So this is great. This is automatable, super easy. Okay, so we know manual process, bad. We don't want to do this stuff manually. We don't want to be typing all the time at the keyboard. It's tedious. We can't remember all the command lines. The tool fragmentation means if we want to train somebody on our process and there's 12 tools, we have to train them on 12 tools, and then they're going to forget, and we're going to get angry at them. So we want to make this easy. We want to make this quick. One push of a button, you're done. So let's adjust our thinking. Okay, if we think of each of these tools as a module, as a piece of our process, then what we need here is not just like one tool or one script. We need a framework, right? As our landscape changes, we need to be able to drop stuff in. We need to be able to code stuff up quick and put it to work without, you know, a lot of pre-work, a lot of training to do so. And I'm going to hand it back to Jason so he can take it from there.
So even that, you might not have the buy-in to do, right? Creating your own framework might be too much, right? I mean, you don't have the expertise. You don't want to take time to do the research on which methods and classes constitute those vulnerabilities, and that can be an issue. What we're going to do today is we're going to show you our framework that we made that does everything in this presentation, and we've kind of spilled the guts to you. The thing we didn't reveal to you is specifically which classes and methods that we look for, and we can't do that, but we are giving you the tool to use in a form that if you don't have time to write your own framework, you can use it. So we'll kind of show you what that looks like right now. So we're going to switch over to Dawn's MacBook, and what we're first going to do is we're going to show you the framework that we created in Bash that wraps all these things together. We call it Risker. We're moving it over. So this is running on Dawn's jailbroken device right here. These are all of the apps that Dawn has installed on her jailbroken device. Would anybody like to see a specific app checked using Risker right now? Sorry, louder. Skype? Okay, so she has to use the App Store to download the app. Oh, you got that? All right, hold on. So the first thing she's doing is she started up the Risker framework. And if you recognize some of this, no, it's fine. Yeah, recrack it, it's fine. Sorry. The first thing you'll notice is it has a prompt, and we're very inspired by Metasploit. We love Metasploit since we're, pen testers, so it looks kind of like Metasploit. So the first thing it asks you, do you want to crack the app? You say yes, and so this is just using Clutch and RAS to crack to try to crack Skype. It will skip this if the app's already cracked it in your cache if you analyzed it before. So the larger the app, obviously, the longer it takes to crack. Dun, 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 dun. There we go. Okay, so the app is now cracked. So the next thing we're going to do is check the information. So this is OTool information. So we can see where the application is installed on the jailbroken device, what our iOS version is. There's some debug information at the top too. The UDID of the phone is important because we don't want apps leaking that unique identifier. We can see the bundle ID, the architectures that are inside of the bundle. So it's just one executable. It's an ARM executable, obviously. It was encrypted, but we decrypted it, and here's the imported frameworks for this application. So right off the bat, do we see anything in the frameworks that we care about? Things that we look for in the frameworks right away are like if they're importing social media and stuff into like a banking app, that's never good, but a lot of banks do that. So there's some ad frameworks in here inside of Skype. Obviously, they're going to deliver you some ads. So this is mostly just anecdotal data, though. So we'll move on to the next stuff. The next thing that the framework does, which we didn't talk about, is dumping all of the classes and methods from the application. And so this is done using a tool called ClassDumpZ, which was in an earlier version of these slides, but we didn't cover it here. What ClassDumpZ does is basically does what I said, right? Since your application has all the strings data in it and it has classes and methods really hard-coded in it, it parses that with all the interface data and information that you would need to understand a class or method in Objective-C. So this tool, our framework, dumps this for later analysis. So automatically you could take this and start looking for it for bad classes or methods that you know you don't like in your app. But this is more just anecdotal data for our testers to look at as we're going through a mobile assessment. Okay, and so if you list checks in this framework, you get a list of both automated and binary analysis checks and dynamic analysis checks. So these are all of the binary analysis checks. So we can check for address book usage, add and analytics libraries that exist in the binary. If the binary has those binary protection flags like pi and arc, or pi and stack smashing protection, and then also is it using the Apple provided memory management framework as opposed to doing memory management yourself, which in Objective-C can be a little painful. We can check to see if the app does Bluetooth, calendar access. These are all types of things that you would see a phone having access to, and they're not verbatim dangerous, but they can be depending on what they're sending over these channels or using these channels for. And so we can run through them because I don't want to re-explain them as we go. So this is just the menu, and then we're going to go check all. So we want to check all of these things. So the first one is address book usage. So this app does access the address book. It loads all of the contacts and individual contacts for usage. So obviously Skype is going to integrate with your address book. So this might not be a vulnerability. The vulnerability might come when they try to send that data somewhere. And we're going to see the URLs that they interact with later. So we'll keep this in the back of our head. So then we search for ad and analytics libraries. We look for some of the top ones, so Google Ads, Flurry, Medialets, MobClick. They're not all represented here. As we find another one that's useful, we add it to our checklist. But obviously Skype uses some ads, and I don't think I have a check written here to find what framework it's using for ads. But this is where that would show up, and it would give you an alert. So these are all things related to binary protections and code quality. So does the application have pi enabled? This one does, so that's good. Does it have stack smashing enabled? It does, that's good. Does it use automatic reference counting? It does, so that's good. Has it stripped developer names and paths from the binary itself and stripped symbols? This one has not. So you can see the developer's name in the binary. Now this is interesting. A lot of people come to us and say, why is this a big deal? My developer's name is in my binary. Well, we've had multiple assessments where if you just start Googling this name, you're going to get somebody's GitHub, obviously, or somebody's code, whatever code repository they do. And we've had multiple assessments where people stored code that they used in the app publicly for free online. So we had an assessment where we just Googled one of our developers, and basically he had been fired from the company we were assessing. The developer had been fired, but his name was still in the binary. We found him on GitHub. He had stored their private SSH keys, their SSL certs, or private SSL certs, all of their source code online on GitHub for everybody to have. So that is why this matters. This kind of stuff matters. We do a little bit of extra research when we do a mobile assessment. And so, you know, how do you, go ahead.
I was going to say, and in case Jason has now scared you and you're wondering how to get this out of your binary, we will have an upcoming blog post to cover that because we do get a lot of questions about what Xcode settings do I need to use to strip this stuff out so people can't see it, and it's not intuitive. So we're gonna do a whole blog post covering this particular issue and how to remediate it.
Yeah, and so this is just one of the vulns. This is showing the path or the home directory of the user that used Xcode to develop this application. There's a lot more path information inside this binary. If this alerts, then we can start looking at folders where he's stored libraries that he's importing into the app, things like that. So we get a lot of information about his specific laptop. And then the easy way to fix this, I mean, there is programmatic ways to actually strip out paths and stuff like that. The easy way to fix this is actually just to use a generic developer account like dev1 or, you know, dev something on the Mac, and then compile your application using Xcode with that account. And so we'll see an app that has, you know, dev1, which is fine. You know, there's no vulnerability there. So we'll check if the app has access to the default iOS Bluetooth library. So this one does not. Does it access your calendar data? It does. Does it use depreciated crypto methods? And depreciated, we use a little bit of a wide berth here, but MD5, SHA-1, you know, have been cracked in some instances. So if they're storing things in MD5 and it's in a rainbow table, you can go look up the MD5 data. So we'll know that when we're looking through the data stores, when we get to the dynamic analysis, that you know, the string values for some of the SQLite storage and stuff like that, you know, might be MD5. You know, it's not gobbledygook. Let's just go start looking for stuff in MD5 or SHA-1. So this is the data protection API one, which is interesting. So the application doesn't use the data protection API global class. So this will tell us that, but then the next check will actually tell us which files in specific have designations piecemeal. So right now it's parsing all of these out of the files.
And in this case, this is a good instance. This particular check will be more accurate in the case that we already launched the app and logged in and allowed it to drop whatever files it's going to drop. I'm going to shrink this.
Yeah, so she fixes the window. I'll just kind of explain what happened here. So we took all the files that the application dropped and we started checking which ones had data protection classes. Now, Apple in iOS and the newest iOS has applied a data protection class to every file, trying to fix this problem of no encryption on files, right? And what this means basically is that if there's no data protection class and you're working on iOS 6, if you lose your phone, even if the PIN is enabled, you can still pull data out of this app folder if you just plug it into a computer. So if you lose your phone, somebody can grab your data. It's that simple with no data protection class. Now, they added a data protection class to files, or to all files, but it's the minimum stringent, or the minimum class of the data protection classes. Basically, the rule is, I think, you can put in as long as your phone has been powered on once and the PIN has been entered once, it's in that state, the files are unencrypted. So to us, that's still bad, right? Because, I mean, who has a phone right now? Who turns off their phone all the time? Who hasn't put in their PIN? That's the default state of most phone apps or iOS apps ever. So, so if it has the weakest one, we tell you. If it has none, we tell you. And here you can see this one's interesting because Skype uses URL caching, which is inside this directory at the bottom of the screen. Sorry. And so there's some interesting vulnerabilities around URL caching in this with this cache.db file. So what happens when you have this file on your phone and you visit a URL, or the application uses NSURL, which is, you know, a network connection class or method, the post data gets basically put into this cache database file. And so if you're not familiar with the fact that this does this by default and you haven't turned it off, then post data obviously includes your username and password. So this is a lot of times where we find leaked usernames and passwords in plain text during these mobile assessments. So this gives us a good place to start looking. We know that they're not using data encryption, and that's good stuff. We have two more checks that check for specific types of files, so SQLite files, databases, and plist files, which are used for data storage. Oh, we have 5 minutes. We have to rush. Okay. So this just gives us a list of things to look for those file types, and we can go look at them doing, just checking the file system. So we're going to check for if the app has geolocation usage. This one does use geolocation. We're going to check if the application does any kind of jailbreak detection. This one doesn't. Does the application do keyboard caching, right? So when you're entering in data into a form field, does it cache that data? This one doesn't have that vulnerability. Does it use a shared keychain? Nope. Does it log to the console? Yes. So there's some logging going on in this app. You can check the Apple System Console inside of iTunes to see exactly what it's logging, but this lets us know that it is, so we can go look at that right away. Pasteboard, copy and paste, the buffer that does all the copy and paste data, is that being cleared or being basically secured correctly? We don't see the method for that, so we alert that it might be a vulnerability. Photo storage, are they storing photos to the public photo roll, which all other applications have access to? Are they using push notifications? Good. They are using push notifications. Are they doing iOS backgrounding correctly, where the app takes a screenshot to reload? They are. Is there client-side SQL injection? Are they using depreciated methods for SQLite inside of that application? Are they using certificates correctly? We can check that. Are they using temporary directories to store some data that are accessible by other applications? They are. So they're using vartemp for something. URL schemes, have they instantiated or are they using URL schemes to communicate with other apps on the iOS phone? So they are. They're using telephone numbers. They have a web service protocol here that they've created, things like that. Then what URLs are they talking over? So here is a list of URLs that they instantiate over HTTPS and nothing over HTTP, so that's good. Are they leaking UDIDs? No. Are they sending passwords or registration information over HTTP? No. So this is the framework that we wrapped all those checks with and all those tools if we made it ourselves. We also made a fun website for you guys to use. So this is hprisker.com. You can go there, register, and basically you can submit an application that you want checked, and you can use this in your BYOD program. And then just select an app. If we have it in our database, it's already there. You can search for it. If we don't, we'll put it in a queue and run it. But these are apps that we've assessed. So you can see Adobe Reader has some logging enabled. There's clear text submission of account data in some instances. So you can go here and look at your apps and start seeing what private data they deal with. And so we had 5 minutes, but any questions from this? Yeah. So since we're not working with it at runtime for most of these things, we don't have to worry about the jailbreak protection, but we do check to see if they're doing it. But there's multiple ways to defeat jailbreak detection. You can use a runtime tool, you can beat it in GDB, you can patch out whatever path they're looking for in iOS. So if they're looking for .cydia to be installed as part of their jailbreak routine, you just change it to the other 5-letter character or whatever, and you patch it out and then use that. So, but that's how we do it in tests, right? But none of this requires that. So, the dynamic check too. Yes.
Do you have plans to extend this to Android?
Yes, Android is actually being worked on right now. So Android is actually super easier because we're doing strings analysis of binaries right here, which we don't have source code for, right? We still get class and method names inside of a binary, but with Android, you can decompile all the way down to pseudo source, and we can look for way more things in Android. That's why it's actually taken longer for us to do Android, because there's more stuff that we can do, and we're trying to make it super snazzy. So, yes?
Do you plan to make this framework available for offline analysis, or it's just the website right now?
It's just the website right now. I mean, it's a cool idea. We launched it with the web GUI. You can use, the output of the tool. We gave you the roadmap to build the framework yourself, but we didn't release our specific framework because it's, obviously owned by HP. So.
Any plans in the future?
I don't know. We'll talk it over and we'll see. We tried to make it as transparent as possible on how we're doing it so you could do it yourself, but we'll see. I mean, it depends on how the community reacts once we launch this. There's a press release going on about this thing right now. I don't know. I don't deal with the press release stuff, but you know, once we get some responses, if people really want to see it, I don't know. We'll see what happens.
So how do you, okay, one final question. How
Sure.
do you get around the, if iOS 7 oddities with jailbroke not available yet and stuff like that? Any ways to get around that with dynamic assessment?
Well, you can still do a pretty good mobile app assessment without a jailbroken device. You know, all of these things, I don't know, you can do most of them without a jailbroken device, but if you're going to make this framework, you're going to want to make it on, you know, on a jailbroken device. So you just have to keep one in your lab at an old version that is jailbreakable, right? And so the time to exploit for a jailbreak is about 7 months. So if you can wait 7 months, then you can make a new one in 7 months. So, yeah. Yeah, I have an account on here, so it shows what apps I've searched for. Yes, this is my account, right? It's not public. I mean, these are apps I've added to my profile. You can see Welcome J Haddix here. So, yeah. No, these are apps from the App Store. So I use Adobe on my phone. I use AD People on my phone. Yes. Yeah, so I mean the framework, if you wanted to use it internally, yeah, you can't use the website for like all the fancy stuff internally, but if your app's on the App Store, if you put it on the App Store, you can search it in our database or add it to the queue and it will get analyzed. You can get the results from the tool, yeah. Any other questions? Dawn, do you have anything else? Nope. Okay, cool. That's the presentation. Thanks, everyone.